Hello everyone, welcome back to my channel. As you all know that I am Monica pursuing my Information Science and Engineering course at Sri Venkateswara College of Engineering, Bangalore. Today I am going to discuss about the subject called Analysis and Design of Algorithms, particularly about the topic called Decrease and Conquer method. Few contents present in this topic are Introduction, Key Characteristics, three major variations which include decrease by a constant, decrease by a constant factor, variable size decreases, and conclusion. Let us discuss Introduction to Decrease and Conquer technique. Decrease and conquer method is based on exploiting the relationship between a solution to give instance of a problem and a solution to its smaller instance. Once such a relationship is established, it can be exploited either top down or bottom up. The bottom up variation is usually implemented iteratively, starting with the solution to the smallest instance of the problem. It is called sometimes incremental approach. Key characteristics. Single subproblem focus. Unlike divide and conquer method, which splits a problem into multiple subproblems, decrease and conquer focuses on reducing the problem to a single, smaller subproblem at each step. Incremental solution building. Solutions are built by solving smaller instances and combining the results to solve the larger problem. Implementation approaches include top-down implementation. The problem is broken down into recursively until base case is reached. Bottom-up iterative. The solution starts from simple and builds up to solve the original problem. Three major variations include the decrease and conquer method is a problem solving strategy where you reduce the problem to a smaller version of itself, solve the smaller problem, build the solution to original problem using smaller solution. There are three major variations of decrease and conquer method: decrease by a constant, decrease by a constant factor, variable size decrease. Decrease by a constant. Decrease by a constant means at every step you shrink the problem by same fixed amount, usually by 1, until the problem becomes simple enough to solve directly. You remove or solve one small piece of the problem at a time. Then you use the solution to build up the answer to the original problem. Simple example is factorial computation. To compute n factorial, we first compute n minus 1 factorial and then multiply the result by n. Each step decreases n by 1. In decrease by a constant variation, the size of an instance is reduced by the same constant on each iteration of the algorithm. Example code: define factorial of n. If n equals to 0 or n equals to 1, it returns 1, else it returns n star factorial n minus 1. Every call reduces n by 1, exactly the decrease by a constant idea. Decrease by a constant factor. The decrease by a constant factor techniques such as reducing a problem instance by same constant factor on each iteration of the algorithm. In most applications, this constant factor is equal to 2. The decrease by half idea is illustrated in figure. For an example, let us revisit the exponential problem. If the instance of size n is to compute an instance of half its size, it's to compute an by 2. But since we consider here instances with integer exponents only, the former does not work for odd n. If n is odd, we have to compute an n minus 1 by using the rule for even valued exponents and then multiply the result by a. In variable size decrease, the size of problem doesn't shrink by just 1, but a variable amount. It should shrink by 2, half or 5. Any amount that can be changed each step. Key points about variable size decrease. The size reduction is not fixed. It depends on input at each step. Each step makes a significant dent in the problem size. often leads to faster algorithms compared to reducing by just one each time. Example, binary search. In binary search, every time you check the middle of the array and throw the away half of the array, problem size reduces by half every step. The amount of decrease depends on the current size. In decrease and conquer technique, I can conclude that it is a powerful and widely used strategy in algorithm design. It works by solving smaller version of problem first and then building up to full solution. By gradually reducing the problem size either by constant amount, a variable amount or fraction, algorithm becomes simpler, more efficient and often easier to implement using recursion. This method is the foundation behind many important algorithms which include binary search, insertion sort and Euclidean algorithm for GCD. Overall, decrease and conquer provides a clean, effective way to break down complex problems into manageable steps leading to optimized solutions. Thank you.